Okay, this is exercise set 1.2. The title is Systems of Linear Equations, 2 Variable. Calculator solution using the graphing feature of the TI-84 Plus. We're encountering single point solutions in this exercise set. The instructions are here. Part A, is the system linear, 2 variables? If not, state this and explain the reason. If so, proceed to answer parts B and C below. Alright, so if we do have a linear system, 2 variables, we would go to part B here, which is solve the system using the graphing feature of the TI-84 Plus calculator. Record what you have entered into the y equals 2 edit screen. Record exact answers if you are able to by using the calculator's fraction conversion feature. If not able to do this, explain the reason and then record decimal approximations rounded to 3 significant digits. Part C. Use the calculator to perform an algebraic check of your solution. Record the result. Here's exercise number 3. Let's take a look at this system. The first equation is in the form ax plus by equals c. So that's a linear equation. The second equation, this has the form ax plus by equals c. It's linear too. Okay, this system is indeed linear and 2 variables. Part A, yes. This is a linear 2 variable system. Well, that means we're responsible for part B of this, which is to now solve this on the TI-84 Plus calculator. Alright, so solving a system, we are looking for the intersection of these 2 graphs. In this case, the 2 graphs of these equations. To get that on the calculator, we'll need to solve for y in each case. Now, looking at this system, there's a lot of these decimal numbers here, all hundreds, all throughout. So even though we're using a calculator, sometimes it's up to you, but I think this is a chance to do a little bit of manual preparation before even using the calculator. So for this first equation, maybe we decide to multiply both sides by 100 and have the first equation be rewritten as 5x minus 3y equal to 21. The second equation, multiply both sides by 100 there and have 7x plus 2y equals 16. Alright, from here, this is a little easier to solve for y. In this first one, we could have a y1 equal to, let's see, subtract 5x from both sides. Multiply both sides by -1, and then divide both sides by 3. We'd then have, parenthesis, 5x minus 21 divided by 3. Okay, the second equation. Y sub 2 equals, how to solve for y here? Subtract 7x from both sides and divide both sides by 2. That would have 16 minus 7x divided by 2. Alright, we're ready to go to the calculator. Okay, at the calculator, we could go to the y equals 2 edit screen. Put here our y sub 1, which is parenthesis 5x minus 21 parenthesis divided by 3. Okay, let's put in our y2 here. This will be parenthesis 16 minus 7x parenthesis divided by 2. Alright, we might decide to get things started by looking at a standard coordinate system for the TI-84 Plus that means a coordinate system with an x-axis from -10 to +10 and a y-axis from -10 to +10. We get that by doing a zoom 6. Okay, looks like the single point intersection has appeared right here on this coordinate system. Now we can go ahead and have it calculated. That will be second, calculate, intersect. Alright, let's move the cursor over a little bit. That looks like a good first curve for our system. Enter. Where the calculator cursor is blinking now, it looks like a good second curve for our system. Enter. Let's take a guess graphically. So let's move the cursor, calculator cursor, a little over to the right. About there looks pretty good. Say enter. Okay, now we were supposed to try to obtain exact answers if we can. So let's return to the home screen and see what we can do here. We can go x, math, fraction, enter. Okay, got 90/31 for x as an exact answer. And for y, alpha, y, math, fraction conversion, go. Okay, we got an exact y also. Let's record this on our paper. We can say the solution is 90/31 -67/31. Since this is a conclusive statement, put it in a nice prominent cloud so that it jumps off the paper for anyone reading our solution. Alright, now, could be wrong. Let's try checking things over. In a situation like this, one of the most powerful checks is to go to the original equations before anything started and see if, upon substitution, this solution makes each equation in the system true. Alright, and we'll have the calculator do the arithmetic. So the left-hand side of the first equation is 0.05x minus 0.03y. Let's see what that comes out on the calculator. And the second equation's original left-hand side is 0.07x plus 0.02y. Let's see what the calculator computes for that. Here at the calculator, we might decide to just clear the home screen and take this first left-hand side, 0.05x minus 0.03y, and enter. 0.21. Ah, good. Just as in the original first equation. Okay, second equation. Its left-hand side. 0.07x plus 0.02 alpha y. Enter. 0.16 as in the first equation. Great. Let's record this on paper. So the calculator came up with, in this first case, a 0.21, which, comparing to the original equation, is just what we were hoping to see. That's a check. And the second equation, the left-hand side on the calculator, turned out to be 0.16. That is the same as the original second equation, right-hand side. That's a check too. Okay, this solution is looking good. Exercise 4. Alright, do we think this system is linear two variables? In the first equation, Here's a problem right here. A square root of x appears. That's not a linear term, this 3 square roots of x. So this could very well disqualify this equation from being linear. Sometimes you take one more look to make sure that if you did something algebraically, could you rewrite it as a linear equation? But in this case, what really can you do? If you were to isolate the square root of x on this side, or even isolate 3 square roots of x on this side, in other words, if you did like this, 3 square roots of x equals to 7 minus 4y, and then you squared both sides as a kind of a desperate effort to get rid of the square root of x here, this would now leave you with 9x, so there's some success there. But here you have to square this binomial, and the special product here would be 49 minus 56y plus 16y squared. Well, now we've got another nonlinear term. Alright, no doubt about it. This first equation's not linear, and therefore the whole system is not linear. So let's record this and provide a reason. So A, no. This system is nonlinear. And how about that reason? Well, most fundamentally, it comes back to this first equation and this 3 square root of x term here. That was what defeated it. So we could record the first equation has a 3 square roots of x term, and is thus nonlinear. Therefore, the system is nonlinear. Alright, and with that kind of conclusion, we are done with this question because this exercise set only has us solving the linear systems. Okay, here's exercise 5. Let's take a look at this system as far as being two variables linear. The first equation is in the form ax plus by equals c, linear. The second equation, also already in the form ax plus by equals c, so linear. Alright, the system is indeed linear two variables. So A, yes, the system is linear two variables. Okay, and this means we are responsible for solving the system with the TI-84 plus. Alright, if we want the calculator to do this graphically, we need to have y solved for in each case in order for the calculator to graph the solutions. So let's take this first equation, solving for y, not so bad here. Subtract 4x from both sides, divide both sides by 3. We could have y1 equaling to negative 7 minus 4x, divide by 3. In the second equation, we could subtract 3x from both sides, divide both sides by 11. We'd have a y sub 2 equal to 13 minus 3x, divide by 11. We're ready to go to the calculator. Okay, at the calculator, let's go to that y equals 2 edit screen. And y1, we've got a parenthesis. Now, careful here. There's the negative sign in front of the 7. It's followed by the subtraction sign, 4x. Parenthesis. divided by 3. Okay, let's go to y2, where we have parenthesis 13 minus 3x parenthesis divided by 11. Alright, well, let's start off with the coordinate system with the x-axis going from negative 10 to positive 10 and the y-axis going from negative 10 to positive 10. We find that by using the zoom standard. Zoom. And number 6. Okay, right on this coordinate system itself, we see the single point intersection. And by the way, as each graph here is a straight line, so we know that this is only this single point intersection. There are no other intersections that we don't see in the calculator. We know that because we know we have two straight lines. If they intersect as they do here, they do not intersect any other time. Okay, so let's go ahead and get this. This means second, calculate, intersect. Let's see, I'll move the cursor a little off the axis there just to make it more clear. Alright, could this be a first curve? Yes, say enter. Could that be a second curve there? Yes, by pressing enter. I guess navigating the calculator cursor a little to the left, about there, enter. Now, we were required to find exact solution if we are able to. Let's try it. Second, quit, home screen. Let's take a look at x, math, fraction, enter. Okay. Got an exact rational fraction for x there. How about y? Alpha, y, math, fraction, enter. Okay, great. Let's record the solution on our paper. We're able to write the solution is this ordered pair here with an x-coordinate negative 116 over 35 and a y-coordinate of 73 over 35. Alright, I like the conclusive statement to be most prominent so that it contrasts nicely from all the little scratch work in the background. Okay, now we've got that there. Let's check. Could be wrong. Two sources of error, right? One source, the rewrites here or rather the solving for y here in each of these two cases. Secondly, keyboarding. Putting this into the calculator could have error there. Alright, a strong check for such a situation is to use the original equations. Let's make sure that this claimed solution really does make each equation true and have the calculator do the arithmetic. So, for the first equation, its left-hand side is 4x plus 3y. We'll see what that turns out on the calculator. The second equation, its left-hand side is 3x plus 11y. Let's see how that turns out on the calculator. Okay, here at the calculator, the left-hand side of that first equation is 4x plus 3 alpha y and enter. Negative 7. Okay, that is the same as the original equation. Good. Alright, the second part of our check. The left-hand side of the second equation is 3x plus 11 alpha y, enter. 13. Nice. Same as the original equation's right-hand side. Okay, let's record this on our paper. We have found 4x plus 3y upon substitution of this x and y solution here is -7. That is the same as the original equation's right-hand side. That's a check. The second equation left-hand side, 3x plus 11y. Calculator determined this sums to 13. That's the same as the original equation. That's a check too. Alright, this solution overall now looks really good. Here's example exercise number 6. Let's look over the system to see if we think it's linear, two variables or not. First equation has the form ax plus by equals c. That's a linear equation. The second equation also has the form ax plus by equals c. That's a linear equation too. There's two variables, so part A, yes. This is a linear system, two variables. Bringing us then to part B, where, since it is a linear system, two variables, we are to solve it with the TI-84 Plus calculator. Okay, to do this, we need to get the graphs of each of these equations in the calculator. We need to solve for y in each case so the calculator can go to work. In the first equation, we could subtract x over 9 from both sides and multiply both sides by 22. We would have a y1 equal to -1 minus x over 9 times 22, like so. In the second equation's case, to solve for y here, we could subtract x over 5 from both sides and then multiply both sides by 15. We would have y sub 2 equal to 1 minus x over 5 times 15. Okay, time to go to the calculator. Okay, at the calculator, we can go to the y equals to edit screen, and in y1, we can put our 22, parenthesis, -1 minus x divided by 9, parenthesis. Okay, and our y2, we've got 15, parenthesis, 1 minus x divided by 5, parenthesis. Alright, as a starting coordinate system, probably the standard one is a good place to at least get started, and for that, it's a matter of going zoom, standard number 6. Okay, well, we do see two straight lines, and their intersection appears to be down low in the largely negative y vicinity. Okay, at first, maybe we could do a zoom fit to actually change the y-axis only to get these lines to appear. Maybe we'll start with that. So that's a zoom, and 0 is actually the fit. Okay, having seen this, it looks like the intersection is rather far to the right. Okay, maybe we could go and change the window so that there is more positive x-axis. Let's go to the window. Let's change x max. We'll just take a guess. Maybe if it was 500, that would be sufficient to expose the intersection. Now, this alone will end up giving us an intersection that's off the display, almost certainly. So also, let's try doing a zoom fit at the same time. Zoom 0. Let's see what happens. Okay, the intersection appears to be actually not nearly so far out as the 500, so let's go back and maybe change the window not so much. So maybe let's make X max 200. Okay, and then let's do a zoom fit. Zoom 0. Okay, now we have a rather clear view of the single point of intersection, which will be our single point solution. And now let's go and get it calculated. Second, calculate, intersect, number 5. Okay, is that our first curve? Could very well be. Say enter. Is that a second curve? Yes, enter. I guess. Alright, let's move that calculator cursor over. About there, looks like a guess. Say enter. Okay, we have these this intersection here. Let's go ahead and see if we can't get this recorded exactly on the calculator. Second, quit. Let's take a look at X. Math. Fraction, go. Okay, 333 over 5. How about that Y? Alpha, Y. Math. Fraction, go. Okay, negative 924 over 5. And also in this case, you notice those decimal representations were only about 4 digits long, which indicated even those decimals were themselves exact. But okay, we can record either way in this case and be recording exact answers. So let's go ahead and record this on the paper. So we can write the solution is 333 over 5 negative 924 over 5. Conclusive statement. Alright, now let's check things over. Time to go to the original equations and see if upon substitution this x and y make both of the first equations true. And let's take the left-hand side of the first equation, x divided by 9 plus y divided by 22. See what the calculator gets when it computes that. And the left-hand side of the second equation, just x divided by 5 plus y divided by 15. We'll see what the calculator gets when it calculates that. Alright, let's go to the calculator. Alright, perhaps we clear the home screen here and start with our first equation's left-hand side. That was x divided by 9 plus y divided by 22. Enter -1, which is the same as the right-hand side of the first equation. That's good to see. Now, the second equation, its left-hand side is x divided by 5 plus alpha y divided by 15. And enter. 1. Just like the original equation. This looks great. Let's record this on our answer sheet. Okay, our calculated result of the x over 9 plus y over 22 equal to -1. That's as in the first original equation. That's a check. The second equation, the sum of x over 5 plus y over 15, it came out to be 1, and that's the same as the original equation. That's a check too. So it looks like we're pretty confident this is indeed a correct answer. Okay, exercise 7. Take a look at the system. This first equation could be seen to have the basic form ax plus by equals constant. The second equation is already in the form ax plus by equals constant. Okay, both linear equations, two variables, ready to answer part A. Yes, this is a linear system, two variable. Alright, so now we need to try to solve it, assisted with the TI-84 plus calculator. To do this, we'll need to get the graph of each of these equations. For the first equation, we need to solve for y for the calculator usage. In this case, that would mean add x over 20 to both sides and multiply both sides by 15. We'd have y1 equal to 15 times the quantity 1 plus x over 20. In the second equation, to solve for y, subtract x over 25 from both sides, multiply both sides by 12. We have y sub 2 equaling to 12 times the quantity 1 minus x over 25. Okay, let's go to that calculator. Okay, at the calculator, let's go to the y equals 2 edit screen. The formula for y1 we've developed is 15 parenthesis 1 plus x divided by 20 parenthesis. Okay, let's go down here. Here's 12 parenthesis 1 minus x divided by 25 parenthesis. Alright, there's our y2. Now, for a initial graph, why not the standard coordinate system? That would be zoom 6. Okay, looks like there's an intersection, single point intersection lying up above what we see right here. Maybe in this case we could just kind of take a guess at the window change. We need more positive y-axis, and we can go to the window and we could make y max, let's say 20 or 30, just to be sure, or more sure that it appears. Okay, let's try that. Now we'll push graph. Okay, a single intersection is right there waiting for us to calculate. Second, calculate, intersect. Alright, I'm going to move the calculator cursor off of the axis to more clearly see what's going on. Is that a good first curve? Yes. Enter. Is that our second curve? Yes, it is. Enter. A guess. Let's move that calculator cursor over to about there and say enter. Okay, let's try to achieve exact answers if we can here. So second, quit. Let's take a look at that x, math, fraction, go. Okay, you got an exact x coordinate. Can we do the same for y? Alpha, y, math, fraction, enter. Okay, we are succeeding here. Let's record this on our paper. We're able to write The solution is negative 100 over 41, 540 over 41. Okay, this is conclusive. I like it to be prominent. And it could be wrong though, right? Alright, so let's check this over. Using the original equations, this point, when substituted into the original equations, must make them both true. Otherwise, it's not a solution. So let's take the left-hand side of the first equation, y over 15 minus x over 20. See what the calculator comes up with when it computes that. And as far as the second equation goes, its left-hand side is x over 25 plus y divided by 12. Well, let's see what the calculator arrives at for that. Here at the calculator, perhaps we clear the home screen and take the first left-hand side of an equation. That would be the alpha y divided by 15 minus x divided by 20. Enter. 1. As in the original equation. That looks good. Okay, the second equation's left-hand side is x divided by 25 plus alpha y divided by 12. And enter. 1 as in the original equation. Okay, let's record this on our paper, and we've got it. So according to our calculator, this left-hand side summed to 1, same as the original equation. It's a check. This left-hand side also summed to 1, which agrees with the second original equation. All right, there we are. Looks good. Exercise 8. Let's have a look at this system. The first equation has the form ax plus by equals c. It's linear. The second equation, okay, right here. Here we got this y squared term. That's not linear. And there's no algebraic manipulation that's going to make that disappear at all without causing other bigger complications. So here we are in part A with the response of no, this system is not linear. Alright, and what's our reason for saying this? Okay, it's that existence of a negative y squared term in the second equation. So we could write the second equation has a negative y squared term and thus is not linear. And once you have an equation being nonlinear, the entire system is nonlinear automatically. So therefore, the system is nonlinear. Alright, under these conditions, we are not responsible for solving the system as it is not a linear system, two variables. So we're done. Exercise 10. Let's take a look at this system. The first equation has the form ax plus by equals c. That's linear. The second equation, okay, the y's come first, the x's are second, but could be rewritten as ax plus by equals c. It's linear. All right. Part A. Yes, this is a linear system, two-variable. Okay, this means we're responsible for part B, which means solve, assisted with the TI-84 Plus calculator. All right, to do so, we'll need to solve for y in each equation's case. This first equation could subtract x over 27 from both sides and multiply both sides by 22. We'd have y sub 1 equaling 22 times negative 1 minus x over 27. In the second equation's case, to solve for y here, could add x over 7 to both sides and then multiply both sides by 3. We'd have y sub 2 equaling 3 times the quantity x plus x over 7. Alright, we're ready to go to the calculator. At the calculator, let's go to the y equals 2 edit screen. And for y1, we have 22 parenthesis negative 1 minus x divided by 27 parenthesis. Alright, let's go to y2, where we have 3 parenthesis 10 plus x divided by 7 parenthesis. As our initial coordinate system, let's use that standard one. That means zoom 6. Nothing whatsoever appears. Okay, we could try doing a zoom fit. That will be the one that changes the y-axis to whatever it takes to force the graph to appear. Okay, now it appears that there will indeed be a single point intersection, but it's way to the left of what we see here. Alright, we'll need to change the window. We need more negative x-axis. So we can go to the window. X-min, right now it's negative 10. Let's try negative 100. I guess. If we don't like it, we can always change. And while we're here, let's also do a zoom fit to make sure everything appears on our display. Okay, just what we're looking for right there. Let's go calculate that intersection point. Second, calculate. Number 5 is intersect. I like to move a little away to be clear what my choices are. Is that a first curve? Yes, enter. Is that a second curve? Yes, enter. I guess about there, enter. Alright, we're supposed to try to record exact answers if we can. Let's go back to the home screen. Take a look at x. Math. Fraction. Go. Okay. Got an exact x coordinate. How about y? Alpha. Y. Math. Fraction. Go. Okay. Ready to go back to our paper and record a solution. Okay, we have the solution is negative 9828 over 235. The y-coordinate is 2,838 divided by 235. Okay, want to make this prominent. It's a conclusion. Now, maybe it's wrong. Part C asks us to check this. Alright, well, let's see if upon substitution into the original equations, it makes them true. So, back to the original equations. Let's take the left-hand side of each, have the calculator compute the left-hand side, and hope to see the original right-hand side be the result. The second left-hand side is a y over 3 minus x over 7. Okay, time to go to the calculator. Alright, at the calculator, we perhaps clear the home screen and proceed with our first left-hand side. X divided by 27 plus y divided by 22. Okay, enter -1. Okay, that's as in the original equation. That's one check. Second left-hand side is alpha y divided by 3 minus x divided by 7. Enter. 10. Okay, let's record this. This looks pretty good. Alright, on the calculator, this quantity here computed to be -1, which is the same as the original equation. That's one check. Second left-hand side on the calculator became 10, which is the same as the original equation. Check there as well. Alright, this looks good.